Hey everybody, today we're going to look at limiting reactants. A limiting reactant is whatever reactant on your left side of your equation controls how much product can actually be made, because unless you have an exact ratio, one of these reactants is going to run out before the other one runs out. Just like with our practice examples using like sandwiches and things, like the bread will run out before the turkey runs out. It's the same thing with this. Either nitrogen or hydrogen will run out before the other. So let's look at how we would actually do this. Now there's a set of rules that I have written for you right here. And the first step you have to take when you're determining what the limiting reactant is make sure you have a balanced equation. Now in this situation, we do have a balanced equation. I went ahead and balanced that for you. Our second step, we have to convert the given moles of reactant into moles of product. This step will require dimensional analysis twice. Now when it says given, it is referring to the number of moles given to you in the problem. Not the number of moles up here, but the number of moles given to you in the problem. So we have 2 moles of nitrogen gas right there, and we have 5 moles of hydrogen gas. So we have to convert, as it says right here, convert the given moles of reactant into moles of product. What that means, it means we are converting 2 moles of nitrogen gas into whatever our product is, in this case ammonia. Then we're converting 5 moles of hydrogen gas again into ammonia. And they're actually both just one-step dimensional analysis problems. So let's practice with the nitrogen first. So we are given 2 moles of nitrogen gas. That's N2. That's what we are given. We are given 2 moles of N2. Got that from right here. And what it's asking is it wants us to turn that into moles of product. That's what it says in our step 2 right here, into moles of product. Well, what does that mean? What that means is we have to turn nitrogen gas into ammonium right here. Well, how are we going to do that? Well, this is where your mole ratio comes in. We've been working with mole ratios this whole time. Our mole ratio is what we get from the coefficients. So what coefficient is in front of nitrogen? There's nothing, so that means it's a 1. So 1 mole of N2 is equal to, and we get this mole ratio from, again, the coefficients, and we're trying to turn it into moles of product. So what coefficient is in front of ammonia? It is 2. So 1 mole of N2 is equal to 2 moles of NH3. So what have we done here? We've taken our moles of N2 and we have turned it into moles of ammonium. And so then all you do is multiply across and solve just like you do with normal dimensional analysis. So 2 times 2 is 4, divided by 1 is 4. So you end up with 4 moles of NH3. It's important to make sure you put your units. That way you remember that we're solving for moles of NH3. What does this mean? What this means is given this reaction and given 2 moles of nitrogen gas, we can form 4 moles of NH3. So next, it says right here, this will require dimensional analysis twice. That's because you're going to be given moles of both reactants. So we have moles of nitrogen gas, that's this reactant, and we're given 5 moles of hydrogen gas, that's this reactant. So now we have to do the same process, but with hydrogen gas to see how many moles it will produce. So let's look at our problem. We have to start off with our given. You always start off with your given. We've been given 5 moles of hydrogen gas, so 5 moles of H2. Getting that from the problem. The first thing you always write down, you get from the problem itself. The second thing you get from the actual balanced equation, and that's your mole ratio. So here, get this from the problem. Then we get our next bit of information from the actual mole ratio. So we have this right here, 3 moles of hydrogen gas, 3 moles of hydrogen gas. Got that from my balanced equation, 3 moles hydrogen gas. And above that, I got to keep the ratio, so 3, and then I get the 2 from right here, just like we did up there. 2 moles of NH3, 2 moles of ammonia. Just like that. And so then I would cross off moles of hydrogen gas, and we've solved for moles of ammonia. So we have to multiply across. 5 multiplied by 2 is 10. So that equals 10. Then we have to divide 10 by 3 because of this 3 on the bottom. The answer we get is 3.3 repeating. So we get 3 0.33 moles of NH3. Okay, we've done that. Well, what in the world did this just tell us? Let's find out. Let's go back to our steps. Step 3, determine which reactant will make less product. Well, this nitrogen, 2 moles of nitrogen gas, will produce 4 moles of product. 5 moles of hydrogen will produce 3.33 moles of product. So which one produces less? You just choose the lower number. In this case, our hydrogen is making less product. This is how much product will actually be made, and this is your limiting reactant. So what that means is we are comparing, if we are given 2 moles of nitrogen gas and 5 moles of hydrogen gas, how many moles of ammonium will be produced? Whichever number comes out lower is going to be our final answer. So 3.33 moles is how much ammonium will actually be produced. 3.33 moles. And our limiting reactant is whichever of the two reactants produce the lower number. In this case, hydrogen gas, right here, hydrogen gas produced the lower number, 4 versus 3.33. Therefore, H2 equals limiting. H2 is our limiting reactant because it made less. You always just choose whichever one makes less, and that is your limiting reactant. And they're both just one-step dimensional analysis problems. So we figured out our limiting reactant. We also figured out how many moles of ammonium would actually be made. So how many moles of ammonium would be produced? It is 3.33 because that's the lower of the two numbers. You always choose the lower one. And our limiting reactant is hydrogen because it made less overall ammonium. Now, excuse me. Now, there is a final step if we want to figure out how much excess reactant is left over, because if this is our limiting reactant, then this is our excess reactant. So if we want to find out how much is left over, you can do the top number minus the lower number. And so from nitrogen, 0.67 moles of NH3 would be left over if we did that. But that's not what we're concerned with too much right now. Right now I want you to focus on the first 3 steps here: balancing the equation, doing the two-dimensional analysis problems with our mole ratios, and then determining which product makes less, how much product total will be made, and which is our limiting reactant. So this right here, limiting reactant. So we're going to have a few practice problems now. Good luck.